Hey guys, we're going to finish up our lesson checks, right? Okay, or our topic review. So let's do it. It says similarity in right triangles and proportions. So these last two lessons, we're really focusing on 7-4 was mommy, teen, baby, and 7-5 was this like side, bottom types of setups. Okay. So we notice that CD, this segment, is the geometric mean. So if we call that X and the altitude cuts the hypotenuse of the mom in two pieces, then we can set up this ratio, right? And we also know that when we cut an angle in half, see how angle G has been bisected? Then what happens is whatever's here, I'll call this D, I guess, and whatever's here, I'll call that E, and whatever's here, I'll call this F, and whatever's here, we'll call that G. You can set up this ratio side, bottom, and cross multiply to solve. So those are the patterns or the ratios we can set up, and we can trace this all back to similar triangles as well. We're trying to track down how this would work out. Okay, now let's take a look at this other example. Again, here's our baby. It looks like we have right side, left side, and we can do that with the mom, right? Right side of mom is X plus 4. Left side of mom is 9 plus 6. Now this will create a very elaborate ratio. So just dealing with the sides of triangles, we're going to subtract 9 on both sides. I get 6x is equal to 36, and they get 6. And you say to yourself, did mathematicians figure out a quicker way to do this problem? And the answer is yes. We ended up finding out that even not even including the full side, if I take this segment that's left over, so this is the side of the baby, and this is the segment left over of the mom. If I cross multiply these and solve, I can get the same answer. So 9 over 6 is equal to X over 4. Side, bottom, cross multiply to solve. Notice we get the answer much faster. Both ways are appropriate and correct, but this side splitter theorem gets us there faster. Okay, so let's see, which ones would that be? Right here, right? We could cross multiply and solve these. So 32 over X is equal to 20 over 30. Right? Let me see if that makes sense. 32 times 30 is 9. Oops, okay. 960. And then divide by 20. I get 48. We look, yep. 20 is smaller than 32. 30 is smaller than 48. Here, same thing. We can cross multiply and solve these. So 18 over X is equal to 20 over 16. When we cross multiply, 20X is equal to 18 times 16. Get 14.4. Plug this in, and see if that makes sense. So 18 is a little smaller than 20, 14.4 is a little smaller than 16. Here we have our angle bisector. So this angle here at the top, I'll call that angle A, was bisected, so we could set this up side, bottom, side, bottom. 8 over x is equal to 5 over 2.5. And we will cross multiply to solve. So we get 4. Let's see if that makes sense. Yeah, half of 8 is 4, half of 5 is 2.5. That's that same pattern. Okay, now they turned it sideways. So here's our angle that was bisected. So I can do side 9, bottom x. And the other side, side 6, bottom. And so again, if, let's say that x is 3. If x is 3 and the whole thing's 5, then you know this is 2. Well, you say to yourself, well, how did you know that? Well, you took 5, take away x, whatever x is. So if x was 3, 5 take away 3 gives me 2. So this should be the expression 5, the whole thing, take away x. That's what should be there, 5 take away x. So I do side 6, bottom 5 take away x. And that's what I'm going to cross multiply to solve. All right, 6x is 9, 5 take away x. When I distribute, I get 9 times 5 is 45 and negative 9x. All right, let's add 9x on both sides. So I get 15x is 45. Beautiful. Oh, that's weird. I guessed that. And so now we can set this up. Is 9 over 3 the same ratio as 6 over 2? 9 over 3 the same ratio as 6 over 2? And the answer is yes. Both of those reduce to the number 3. 20. Use structure. So given the right triangle, GHJ, with an altitude JK to the hypotenuse GH. So I drew the picture that they're describing here. What is GJ? What is GJ the geometric mean of? Okay, I don't really ask these questions a lot, but we could go like, so what would this one be the geometric mean of? So geometric mean would be, when would GJ end up in both of these locations? All right, so to do that, we have to figure out, well, GJ is the long side of the teen. So long side of the teen. And GJ is the medium side of the mom. So we have to go long side of the mom, which is GH, right? And we have to be consistent here. We went medium mom, long mom. So we got to go medium teen. So the medium side of the teen is GK. So what is GJ the geometric mean of? It is the geometric mean of GK and GH. Let's take a look at that. We know that GK and GH, notice the pink length is somewhere between the orange and the blue length. So technically there's 3 geometric means. We like to focus on the one that's the altitude, but there are 3 different geometric means. Okay, now I skipped them, but we're going to go back to 13, 14, and 15. Let's do it. Okay, so they asked for, they gave me this and this, which we like to call A and B. And so we can find this X. So I'm going to call that X and solve for that. So that's A over X is equal to X over B. And this works because it's the, well, let's fill these numbers in. 4 over X is equal to X over 12. Why does this work? Well, this is the small side of the baby, and the medium side of the baby. And so then when I look at the teen, x is the small side of the teen and the median side of the teen. So that's why that works. Those are corresponding sides. So when I cross multiply, I get 48, and x would be the square root of 48. So about 6.9. Okay, and that looks about right. Now, we mentioned in class today, what if that was not one of your choices? So let's take a look at the square root of 48 and investigate it a little bit. So we did this investigation in class, kind of like the square root of 100. The square root of 48. We noticed that 100 is the same as 4 times 25, and both of these can be written in a simpler way. So we end up getting that the square root of 100 is 10, but we could have gotten it by breaking it in 2 pieces. And I'm breaking it apart into pieces that wouldn't be a decimal. So I know that there's a 4 in here, right? Because I just did that a minute ago. I took 4 times 12. So I'm going to break that apart. And then I also know there's a 4 in there. So I'm going to break that one apart too. So 12 is 4 times 3, right? And so now the square root of 4 is 2, and the square root of 4 is 2, and the square root of 3 is a decimal. I can't break that apart. So I end up getting 2 times 2, which is 4 times the square root of 3. So if it's multiple choice, this would also be 4 times the square root of 3 would be a possible correct answer. And I can verify that in my calculator. So if I take the square root of 3, I get 1.73. And if I multiply by 4, I end up getting 6.9 again. So I can verify that these are equivalent or equal to the same amount. Okay. Now, can I solve for ST here? Right? And the answer is sure. I've got 2 of the 3 sides. So I actually want to go back to calling x the square root of 48 because it'll keep it a little cleaner. So to solve for ST, my short side's the square root of 48. My long medium and my long side ST is what I'm solving for. So I get ST squared is 192. So the square root of 192 is the fraction, the decimal 13.9. And that makes sense. If the medium side is 12, 13.9, a little longer. Now let's investigate SR. So one side is 4, one side's the square root, so 4 squared. The other side is square root of 48. We'll square that. And that should equal SR squared, or RS squared. So when we combine these, we get 64. Ooh, that's exciting, because when I take the square root of 64, I get 8. And so this is 8. So now, the last piece is, well, what if ST wasn't this and wasn't that? Can we break apart the square root of 192? Okay, so let's try to break that apart like we did the square root of 100. Let's see if there's a 4 in there. 192 divided by 4 is 48. Oh, so there might be a 16 in there. I'm going to try that. 192 divided by 16, yeah, is 12. So it's 16 times 12. And I'm going to keep breaking that apart because 12 is square root of 4 times the square root of 3. So the square root of 16 is 4, and the square root of 4 is 2. So I end up getting 8 times the square root of 3. So 13.9 is the same thing as the square root of 192, and also the same thing as 8 times the square root of 3. Thanks for joining me, guys.